What are parallel circuits? It's just a circuit that contains more than one path for the current to flow. We have parallel circuits, we have series circuits. Series circuits, remember, there's only one path for current to flow. So, there you go. Circuits in series, only one path for current to flow. It's just like a loop. Circuits in parallel, it's a circuit that contains more than one path for current to flow. So I'll draw a picture. We have battery here. We have battery. This is battery. Maybe it's Duracell. And then we have like something, maybe like a light bulb here. That's not light bulb. This is light bulb. There, light bulb. It may be shine like this. So it connects like that, but this is a circuit that's in series. There's only one path. However, if I connect a wire that goes here, make another light bulb, well, yeah. Now this is in parallel. This is a circuit that's parallel. Something to note about this: if you remove one of these, like one of these resistors or one of these, or you break one of these lines, then current will just flow through the other one. So if I had let's see, if I had a circuit in series and I break this line here or here, anywhere, if I break this line, the light will go off. Circuits in parallel, if I took this piece out, this light would stay on. If I took this light out, then current would flow through there, and then this light would stay on. So it is possible to remove some components and still have other components work. Now that's a different story if you break your circuit there. If you cut that wire, then yeah, of course there's going to be no power if current is flowing through that way. So it is possible to break it so that nothing works, but that's just like disconnecting from the battery. So yeah, it's possible to remove components from circuits that are in parallel, and it won't disable some other components. It's possible. It's not always going to happen, but it's possible. We had some formulas for circuits that were in series. We also have some different formulas for circuits that were in parallel. So I'm gonna share those right now. So for series, wait a minute. All right. So for series circuits, we had the current being the same throughout the whole entire circuit. So we have that formula. The total current is the same as the current through each component. We also had the voltage, the total voltage, V sub T, that was equal to all the voltage, all the volts through each component or across each component, all those added up. We also know that the total resistance is it has the same formula kind of as the total voltage. That's just adding up the resistance for the first component plus all the rest of them. And then something that actually works for both series and parallel circuits is Ohm's law, which was, this is something that's helpful, VIR, for each component or total in the whole entire circuit. So this is Ohm's law. And that works for both circuits in series and circuits that are in parallel. Now, let's talk about the parallel characteristics. Instead of having the current equal across the whole entire circuit for each component, it was equal current. Here, in each component for parallel circuits, the voltage across every component is equal. So it's kind of like this, however, it's with voltage for however many components there are. So the total voltage is the same across every component and the whole thing. So it's kind of like this current law. This is Kirchhoff's law, but yeah, there we have the voltage formula. The total resistance is kind of weird. It's a weird way of writing it. So I'm gonna show you. I'm gonna write it like this. The total resistance is 1 over the sum of the reciprocals of each resistance. This is kind of weird. We'll practice this with an example, but the total resistance uses that formula. It's much more complicated than this formula, but that's the one for circuits in parallel. And then the current. The current is just all the currents added together, or the total current, sorry. The total current, I sub t. That's just going to be the first current plus the second current. So it's different. All the way up to the nth current plus. So there we go. Those are the characteristics. Those are the formulas. That's how you can calculate things in parallel. And then, of course, you can always use Ohm's law for both of these. Make sure you're writing all of this down. I'm going to do an example in the next video to calculate the different components or the different properties of a parallel circuit. So there we go. All right.